What I wanted to do in this flip video is show you several examples of compound inequalities using intersections and union, ands, and ors. I'm going to keep using the same numbers, but I'm going to keep changing out which way the inequality is going and whether it's an and or an or. So the first one I'm going to start with is x is greater than 2 and x is less than 5. So if I put in the number line, here's where 2 is located, here's where 5 is located. For an and, I need to look at each individual piece. So greater than 2, here's less than 5, and I ask myself, where do they intersect? Where do they come together? What's being shared? Well, in this case, I can see pretty easily between 2 and 5. Okay? So what I'm going to do is I'm going to take the same piece, x is greater than 2, and this time I want to say x is, let's flip this inequality and make it go greater than 5 onto the number line. Here's 2, there's 5, first graph open to the right, second graph open to the right. As you notice, it's changed the direction. If I've changed direction on purpose, I'm still doing the same thing. I'm looking for where these things are shared. So what I see this time, the sharing starts here and continues to the right. It would work exactly the same way if I switch these to less than. The sharing, if I switch this to a less than and switch that to a less than, 2, 5, the sharing starts at the 2. So if I don't have them going in opposite directions, they go in the same direction, I simply do the same thing I did before. Where do they start sharing? Try this one more time. X is less than 2, x is greater than 5. Here's my 2, here's my 5, and I look at them independently first. Less than 2, greater than 5, and I ask myself, where do they share? What do they have in common? In this example with an and, they don't. This is a no solution. There's no place I can be less than 2 and bigger than 5 at the same time. Take these same numbers, let's change it to an or problem. X is less than 3, or x is greater than 7. Well, with an or, I know I can go directly onto my number line. Here's 3, here's 7, less than 3, greater than 7, and it looks like a normal or situation. Going opposite than each other, this is typically what an or looks like. So let's look at x is less than 3, or x is less than 7. Kind of the same thing I did with my ands. I need to see what's going on. Here's the 3, there's the 7. I'm going to put it directly in the number line and see what happens. So I've got the open at 3, got the open at 7, and look to see what happens. What happens is it starts filling the number line in, including filling in the 3 here, and what I really end up getting is just simply this half, where x is just less than 7. Do the flip one more time. Let's do x is greater than 3, or x is less than 7. Here's the 3, here's the 7. Go directly onto my paper here, going bigger from the 3 on up. Well, if I open the 7 here, it's already closed automatically by the 3, and I make the 7 go smaller, closes the 3 up, and keeps going. What do I see? I get everything. I get all reals, I get infinite. So I got, in one case, when I look at the ands, I have no solution, possibly no solution with ands. So I'd record that here. We can possibly have, could have a no solution. And with my ors, I could have the concept of all reals. Could have infinite, could have all reals. So as I look here, I start to hopefully understand a little bit better what it means to be a compound inequality. Now it's just a matter of practicing the skill and making sure we understand.